everyone, in this video we are going to dive into world of deep learning and computer vision. We'll using Python and TensorFlow to build a model for facial emotion recognition. Let's break out the key components of the code. We start by importing the necessary libraries and configuring TensorFlow for the deep learning model. And in this cell we are displaying random images from the dataset, giving us a sneak peek of the data we're working with. And now you can see these are the random images from our dataset. And now we are gonna prepare our data for the training. We set up data generators for training and validation. These generators help us to efficiently load and process images for training our model. And now we found these much of images in our dataset, which have 7 classes. Basically we can say these classes are emotion like happy, sad. We define convolutional and dense layer function to build our neural network. Convolutional layers are used to extract feature from images. In model FER function we are sending inputs to our convolution function. And in first convolution network we send 32 filters with 3 class 3 kernel size that is responsible for detect simple facial features like edges, curves and small textures. These low level features are essential for recognition emotion like surprise and sadness. Now in second layer we increased the number of filters to 64 and used a larger 5x5 kernel. This layer can capture more complex pattern in facial expression. And the third one with 128 filters and 3x3 kernel size. This layer is capable to detecting wrinkles around the eyes or the curvature of a smile. I also added flatten layer to reshape the output from convolutional layers into flat vector, and the subsequent dense layer is used for learning complex relationships. And here the 7 neurons and softmax function are used to make the model capable of classifying images into one of 7 emotion categories and providing of a probability distribution over these categories. And here we are passing the parameters in model underscore FER function, and below that here you can see the summary. I used dot summary function to check the summary. And in last we can see how many total parameters are used to train our model and what is the total parameters. Now we are initializing the model here, and in this cell we are setting the number of training epochs, configuring training step per epoch and validation step, and implementing a callback to save model weights based on the highest validation accuracy. And the preservation of the best performance model. We are saving the model weights with the name of model weights.h5. In this training step we use our model to learn from the data. We define the training parameters such as number of epochs and callbacks for weight saving, and we evaluate the model's performance on the validation data. The history variable stores the training progress, as we can see, which is crucial for understanding how well our model is training.
And here we can see how our model is being trained, what is our accuracy and what is our loss. You can see the loss is decreasing and accuracy is increasing by the epochs. And here the accuracy is this much and loss is 1.645. so in the last we can see the loss is 0.74 and accuracy also 0.72. so the accuracy increased and loss decreased. And here we are evaluating our model by passing validation generator, and in the next cell we are plotting the validation loss and training loss to visualize our model loss. And we can see the loss is decreasing on every epoch. Now let's plot the accuracy of our model, the validation accuracy or training accuracy. It should be in increasing order by the epochs. So here we can see it is increasing on every epoch, and in last we are saving our model in the JSON format.
Here is the GUI part of emotion detection model. In this we are importing various Python libraries including tkinter for GUI, file dialog for opening images file, sklearn for matrix, OS for operations, and libraries related to deep learning and computer vision such as model from JSON for loading pre-trained model, and PIL for image handling, NumPy for numerical operations, and CV2 for computer vision tasks. And here is a function named facial expression model is defined to load a pre-trained deep learning model from JSON and weights file, compile it and return the model. This model designed for facial emotion recognition. Now here is the line for create the GUI window using tkinter. It configures the window size, title and background color. And here is the two line for displaying the labels for image. It will display the label on the processed image. And here is a one.xml file which used to detect faces in an image. Now this script loads a pre-trained model using facial expression model function and define a list of emotion labels. Here I defined a detect function which takes a file path as an argument. It loads an image, converts it to grayscale and uses face detection to find faces in the image. For each detected face, it resizes the region of interest, that is ROI, to 48 cross 48 pixels and uses the model to predict the emotion. The predicted emotion is displayed in the GUI. And here is one more function. The name is show detect button is defined to create a button that triggers the emotion detection process. And upload image function is created to open a dialog from selecting an image file. It resizes and displays the selected image in GUI and provides an option to trigger the emotion detection. Now here is the code of upload image button and where it will display in GUI and the label for displaying predicted emotions, and GUI is designed with appropriate styling and positioning. And now the script enter in the main loop which starts the GUI and listens for user interactions. Now let's run our GUI file so that we can see what we have made with this code, and we'll upload an image and see the emotion.
You can see here how our GUI looks like. Now let's upload the image from our computer. Okay, so let's select this one and we'll predict the emotion of this. So detect emotion. So here we can see the output is happy. So we can see our model is working fine now, and that's it for this video. We'll meet in any other project. So thank you and bye.